Welcome to the breakdown of the 2015 Calc exam. Like all past exams, this should be available on the NZQA website. And like the probability 2014 or 2015 exam, I don't remember which it was, exam, I'm breaking this one into 6 parts as well. Okay, so first section, question 1. A function f is given by f of x is equal to x to the power of 4 plus 2x squared minus 5. Find the gradient of the graph of the function at the point where x is equal to -1. Okay, so we've got keywords here. So we've got find the gradient. They want you to find a gradient. Anytime you've got a gradient there, you need to, and you've only got like an f of x or a g of x or a y, you've got to differentiate. Okay? So we want an f dashed of x of the graph of the function at the point where x is equal to -1. So once you've differentiated, you need to substitute -1 for all of the places where you see x. So on that note, let's differentiate. So f dashed of x is equal to 4x to the power of 3 plus 4x. And this just goes to nothing. Okay? So, replace all the x's by -1. So 1 to the power of 3 plus 4. Okay. We've got 3 -1s. Whoops. So that should be -1 in the end. 4 times -1 is -4. 4 times -1 is -4 again. So the gradient should be -8. And we're done. If you really want, you can say m is equal to -8 at x equals -1. F of x is equal to all of that. For what values of x is f a decreasing function? So here, we're talking about increasing or decreasing. That means we've got to differentiate. If the gradient function at a point is greater than 0, so if it's a positive, it means it's increasing. If a gradient function is negative, so less than 0, it means it's decreasing. Okay? So if we sketch this, the highest power is a 3. If the highest power is 3, then we're going to have a cubic. It's a negative there, so it's going to be a negative cubic. So it's going to look something like this. Whoops, that's a positive cubic, sorry. Negative, so down, up, down. Okay, so if we go by our sketch, we can see that it's decreasing here and here. We know that turning points, the gradient is always going to equal 0. So f dashed of x is going to equal 0. F dashed x is going to equal 0 here too. So that means that bang on the turning point, it can't be negative. Okay, it's neither positive or negative. It's neither an increasing or a decreasing function. So we can say here, so to represent this in numerical values, we need to, of course, differentiate because they want to know where it's decreasing, where the gradient function is negative. So we need to find a gradient function, f dash of x. 8 goes to 0, 3x goes to 3, 2x minus 2x squared. Okay, so here we've got a parabola. Right. Now, from the graph, from sketch, I should say, sketch, can see decreasing before first turning point. And after second. Turning point. Right? Turning points at f dash x equals 0. So now we substitute that into our equation. You don't have to write all of this at the start, but it helps. And I've got the space, so I'm going to use it. Okay, so 0, if f dash of x is equal to 0, I can put the 0 in its place. 3 plus 2x minus 2x squared. Okay. Now, there's different ways you can do this. You can use the quadratic formula to work it out, where negative 2 is your A, 2 is your B, and 3 is your C. Or, if, again, with those same numbers in their place, you can input this into your graphics calculator. So you should end up with x is equal to negative 1 or 3. Okay. So now this is at the turning points. So if we look at the sketch here, the negative number comes first, right? When we do any normal graph, our negative numbers are over here and our positive numbers are over here. So the negative number must come first. So the first turning point is at negative 1. The second turning point is at 3. So that must mean so by sketch and working, now this is calculus, f of x is decreasing when x is, it's only on this side. So is that less than or greater than x is equal to negative 1? It's less than. So less than x equals less than negative 1 and greater than 3. Okay, don't put less than and equal to, because at x is equal to negative 1, the gradient function is 0. It is not negative or positive. Okay, so you cannot say it's a decreasing function at negative 1. Same with at 3. If you wanted to be more rigorous in this and prove it by using calculus, then what you can do is you can say here is you can do all this working to find the turning points and do yourself a little table. Let me think this through. So here we've got x. We want before and after x negative 1. So if we say in the table we have our x values, and then we have increasing or decreasing. Okay. And then we say or turning. Okay. And then you can easily say, you could say -2, -1, which would put us on the turning point 0. Then you can go 3 and then go 4. Okay? And what you'll find is that when you substitute this into the equation, remember you're finding the gradient, so you're substituting it into your gradient function, not your original equation. Then you'll find that, again, that's your turning point. So turning point at -1 and 3. At -2, it's decreasing. At 0, it's increasing. At 4, it's decreasing again. So you can say from this table that, so you could also say f of x is less than, is less than 0. F of x is equal to 0. F of x is greater than 0, and so on, to prove that you know what this means, and then from there you can explain that it is decreasing for those values that are there. I just need to get this out of the way so I can see the next question. Calculate the rate at which the volume of a cube is changing with respect to its length at the instant when the length of each edge of the cube is 5 centimeters. Okay, what is the equation for a volume of a cube? Don't remember? Okay, let's put it like this. We have a line. We don't know how long it is. But regardless, no matter what the line is, we measure it from here to here. And it can be any length, so we'll call that x. Now when we have a square, how many squares of x would we have in here? Well, that's like finding the area, isn't it? So it's just x times x, or x squared. This is the area though. Okay, now if we have a cube, which is basically like, sorry, it's not to scale. I know it's more like a prism. Just bear with me. Okay. Right, we have x over here. Got x by x by x. So we still have our face here, but it's x deep. So what we're doing is multiplying it again by x. So the volume is equal to x cubed, if we call the length x. Length equals x. Then it wants to know the rate. Calculate the rate at which the volume of a cube is changing with respect to its length at the instant when the length of its edge of the cube is equal to 5 centimeters. So it's actually told you at x equals 5. Okay, but with words, this is what it means. Again, when we're talking about a rate, we want to differentiate. So dv dx, okay, or if you went v of x, then you're using your symbols of v dashed of x, but I've used v, so I'm going with my dv dx is equal to, just differentiate that, it's 3x squared. Now, it's asking when x is equal to 5. So this is where we just plug it in. So at x equals 5, dv dx is equal to 3 times 5 squared. Now, that only belongs to the 5. That's why it's in brackets, okay? Because it's just the x that we're doing. So 3 times 25 is 75. Okay. And it's changing at a rate of 75 centimeters. Sorry. Squared. Okay. I'm just going to check how much of this there is. Okay. So I'll stop there and I'll do the next page in the next video. Thanks for watching.